Now let's learn about linear momentum. If a strong body strikes against a light body, the force will be more, isn't it? If an elephant tries to open a door or a small cat tries to break a door, which will break the door? The elephant, isn't it? So when the mass is more and the velocity is more, the linear momentum will be more. The product of mass and velocity of a moving body gives the magnitude of linear momentum. Linear momentum is equal to mass into velocity. Can you memorize this? Linear momentum is equal to mass into velocity. Mass is m and velocity is v. The SI unit of linear momentum is kg meter per second, that is kilogram meter per second, and in CGS system we call it as gram centimeter per second, G cm per second. Do you understand? Now we move on to the Newton's laws of motion. Newton's first law states that every body continues to be in its state of rest or the state of uniform motion along a straight line unless it is acted upon by some external force. We already learnt about this as inertia, isn't it? The definition of force, it gives the definition of force as well as inertia. Force, as already we learnt, force is nothing but push and pull. The force produces or tries to produce the motion of a static body, stops or tries to stop a moving body, changes or tries to change the direction of motion of a moving body. Force has both magnitude and direction, so it is a vector quantity. Now do you understand the concepts of force, children? Let's move on to the types of forces. The next topic, types of forces. There are two types of forces. It is classified as like parallel forces and unlike parallel forces. What are like parallel forces? Two or more forces of equal or unequal magnitude acting along the same direction parallel to each other. Same direction parallel to each other. That is called like parallel forces. And what are unlike parallel forces? If two or more equal forces or unequal forces act along opposite directions, both are parallel to each other, but like parallel forces are in the same direction, whereas unlike parallel forces are act on opposite directions. Do you get that, children? Do you understand the difference between the like parallel forces and unlike parallel forces? Both have equal or unequal magnitude, but the direction is for like parallel forces it will be in the same direction, but for unlike parallel forces it will be in opposite directions. Now we move on to resultant force. What is a resultant force? When several forces act simultaneously on the same body, then the combined effect of the multiple forces can be represented by a single force. This is called resultant force. Now you look into the table 1.1, action of forces on page number 4. The first one, parallel forces are acting in the same directions. You see the diagram here, two parallel forces acting in the same directions. So what is the resultant force? F net is equal to F1 plus F2. F net is equal to F1 plus F2. Whereas in the second example, parallel unequal forces are acting in opposite directions. So what is the F net? F net is equal to F1 minus F2 if F1 is greater than F2. And F net is F2 minus F1 if F2 is greater than F1. Okay, here you can see an example when the direction of the greater force, the body will move in the direction of the greater force. You understand that? Oh, next one, parallel equal forces acting in opposite directions in the same line of action. When F1 is equal to F2, you see both 3n on both sides. So F2 is equal to F1 minus F2. So the F net will be 0. So what are balanced forces and unbalanced forces? If the resultant is 0, then it is balanced force. If the resultant is not equal to 0, then it is unbalanced force. For example, you can see this woman drawing water from a well. This is one example. The next example is force applied with a crowbar. The crowbar uses force to remove the nail, isn't it? Next one, the force is acting on the weight balance. All these are examples of this resultant force. The next one we are going to learn is about equilibrium. What is equilibrium? A system can be brought to equilibrium by applying another force which is equal to the resultant force in magnitude but opposite in direction. It is equal to the resultant force but it is opposite in direction. This is called resultant force. This resultant force is called equilibrium. You understand that, children? The next topic is rotating effect of force. In the rotating effect of force, you see the action of a person opening a door or a person trying to turn a screw. Okay. Now, in the person opening a door, you see the hinges there and the axis of rotation. So, what is the axis of rotation? The axis of the fixed edge about which the door is rotated is called the axis of rotation. In the case of the rod will be turned about the fixed point. This is called as point of rotation. Now, do you understand the difference between axis of rotation and point of rotation? Now, we move on to moment of the force. What is the moment of the force? The rotating or turning effect of a force about a fixed point or fixed axis. That is called moment of the force about the point, or it is called as torque. Torque is equal to capital F into small d. What is capital F? Force. What is small d? Distance. Okay. So now torque is a vector quantity and the SI unit of torque is Newton per meter. Next we go on to couple. Two equal and unlike parallel forces applied simultaneously at two distinct points constitute a couple. Rotating effect of a couple is known as moment of a couple. Okay. So now when you understand a couple, you can see the examples as turning a tap, winding or unwinding a screw, spinning of a top, etc. These are examples of moment of couple. Moment of couple is equal to force into perpendicular distance between the line of action of forces. That is, capital M is equal to capital F into capital S. The unit of moment of couple is Newton meter, capital N, small m in SI system and dyne centimeter in CGS system. By convention, the direction of moment of force or couple is taken as positive if the body is rotated in the anti-clockwise direction and negative if it is rotated in the clockwise direction. Now, shall we move on to application of torque? It is gears, seesaw and steering wheel. We are going to learn about the application of torque with the examples of gears, seesaw and steering wheels. First one is gears. A gear is a circular wheel with teeth around its rim. It helps to change the speed of rotation of a wheel by changing the torque and helps to transmit power. This is the example of gear. The next one is seesaw. Most of you have played on the seesaw, isn't it, children? Since there is a difference in the weight of the person sitting on it, the heavier person lifts the lighter person. When the heavier person comes closer to the pivot point, that is called the fulcrum, the distance of the line of action of force decreases. It causes less amount of torque to act on it. This enables the lighter person to lift the heavier person. So the lighter person goes up and the heavier person comes down. The next example is steering wheel. A small steering wheel enables you to maneuver a car easily by transferring a torque to the wheels with less effort. Have you seen the steering wheel on the car, children? Next we go on to the principle of moments. At equilibrium, the algebraic sum of the moments of all the individual forces about any point is equal to 0. From this illustration, we can say the principle of moments can be written as follows. Moment in clockwise direction is equal to moment in anti-clockwise direction. So, capital F1 into small d1 is equal to capital F2 into small d2. So, F1 into d1 is equal to F2 into d2. That is the principle of moments.